Hello, good morning, good evening, whatever it happens to be when you're watching this video. We are just going to start here with 11.1, which is arc length of a circle. And on Friday or last week, you should have watched a video in Khan Academy that reviewed basically how to do area and circumference of a circle. So we will do a little bit of that in this lesson also, just to remind you in case you needed to do any together, but then we'll move on to arc length. So basic review from before, the circumference of a circle is just the distance around the outside of the circle. And circumference is measured in units, like inches or feet or yards, meters, miles, whatever it happens to be. And if you remember from last week, the way we calculate the circumference of a circle, there are two ways. One is we can say the circumference if we're talking about the diameter, which is all the way across the circle. That would be pi times d, or the diameter. And the other way that we can do it is with the radius, which is 2 pi r. Okay, now we have arc length. What the arc length is basically if we have a circle and say we put an angle in that circle, like that, the arc length is just the distance from one point to the next. So that red would be the length of the arc. Like how many feet did you go? Like if you were walking in a circle, how many feet, inches, miles, or whatever did you actually go on that arc? So an arc length is actually also measured in feet or inches or miles or anything like that. Okay, so you also have arc measure. So arc length is that distance from one point on the circle to the next. If you're talking about arc measure is in degrees. So if we are thinking about arc measure, so let's say we have a circle, and I'll make it nice and easy here. We'll go like that. And if that is a right angle, in degrees, the angle in the middle, that's called a central angle, is 90 degrees. That also means the measure of the arc would be 90 degrees. We can calculate the distance as an arc length from one point to the next. We would calculate the measure in degrees. So say we had, here's another circle, say this was and this is the center of the circle, say this was a 30-degree angle here. That would be 30 degrees would be the measure of the arc. So knowing the difference between arc length and arc measure is going to be kind of important moving forward. Okay, so once again, we've talked about this already. This is basic review. The circumference of a circle, you either have pi times d or 2 pi r. Those are formulas that you need to know. You should have them memorized. You've probably been doing them since junior high, so let's make sure that that's something that you remember. So we're just going to do a little bit of practice, and I'm going to go ahead and, even though we should know these, I am going to go ahead and have a little thought bubble up here. My thought bubble is just going to have my formulas in it. So my two formulas I have is either my circumference is pi times the diameter, or the circumference is 2 pi r. That way I have those formulas available so I don't have to keep going back in case you forgot. So as I'm looking, question 1, circumference of a circle with a radius of 9 centimeters. Well, I know I have radius in the question, which means I should use my formula that includes radius. So I always like to start by writing down what my formula actually is, and then plugging in the numbers I need. So if I'm going to use the radius, it's 2 pi r. And it says we're finding the circumference and the radius is 9. So our circumference is going to be 2 times pi times 9, which would be 18 pi. If we left it in terms of pi, we could call it 18 pi because 9 times 2 is 18. Or if we went ahead and put it into our calculator and we want to use the pi button. When you are doing big ideas homework assignments, they will want you to use the pi button. So a couple of other things that are important to note here is that in big ideas, use the pi button. Do not use 3.14 and round to the nearest hundredth. and use the pi button. Okay, so if we actually, you can do it on your calculator, you can use your iPad calculator, you can use a Desmos calculator, you can use a handheld calculator, but if you multiply 18 times pi, you should get 56.55. And of course, this is a distance around the circle, so we want to make sure we label it with centimeters. Okay, another one, we have the radius of a circle with a circumference of 26 meters. So this time, I have, again, I'm using radius because it says the radius of a circle, so I'm going to use that 2 pi r. And this time it tells me the circumference. So instead of the C for circumference, I'm going to put 26 equals 2 pi r. Well, to get r all by itself, because it's asking for the radius, I'm going to divide both sides by 2 pi. So I would have 26 over 2 pi equals my radius. Okay, so if I put that into my calculator, 26 divided by 2 pi would mean that my radius is 4.14, what do we get, meters. And again, if you wanted to simplify this 26 over 2 pi, 26 divided by 2 is 13. Technically, you could just do 13 divided by pi. Okay, this next one has the circumference with a diameter. The diameter is 5. Well, if I'm using diameter, I want to use pi times d, and I know my diameter, it told me, was 5 inches, and I want to find the circumference, so I would have 5 times d, 5 times pi, and I would want to divide both sides by, oh my goodness sakes, hang on. Sorry about that. I'm going to put in 5 times pi. I don't need to divide anything out there. I have circumference already all by itself, which means I would have circumference equals 5 times pi, which is 15.71 inches. And again, here we have, find the diameter of a circle with a circumference of 17. Circumference equals pi times d. And it tells me the circumference is 17 pi times the diameter, which is what it's asking for. So I need to divide both sides by pi. 17 divided by pi is 5.41 feet. Okay, so that was all review stuff. So this now is actually arc length, which is the new material. And all of this core concept up here basically says is if we have an arc length, we can basically relate it back to the circumference of the whole circle. The way I like to think of it as a proportion. Okay, so we're going to talk about this as a proportion. We've done lots of proportions this semester in geometry. So I like to think of my proportion as part to whole, and we'll talk about what the part is and what the whole is here in just a second. Part to whole equals part to whole. Remember, if we're doing proportions, we need to have everything line up correctly. On one side of my proportion is going to be my angles. Okay, so one side, this side over here, that's going to be my angle side. Okay, so on that side, I would have my arc measure in degrees. That's my part, because if you think about it, that arc measures that part of the circle. And a whole circle, well, we know a whole circle is 360 degrees. Okay, so that's my first part to whole. The other side, so my left side is my degrees. My right side is going to be the part to whole that's talking about the circumference. So the part on top is going to be, on the right-hand side, talking about the circumference, that's going to be the arc length. Remember, that's the part of the circle, just from one part to the next, or from one point to the next on the circle. And all the way around the circle, the whole is going to be our whole circumference, which is 2 pi r, or pi times d. That can be either one. So we're going to go back to this idea on all of these questions. We're just going to set up proportions and we're going to cross multiply or use the butterfly method, however you like to think about it, in order to find any of those missing pieces. Okay, so let's take a look here. I have on one side, okay, it's asking me to find the arc length. Okay, so I'm going to set up my proportion on one side. I have my degrees. Well, I have 60 degrees. That's the part. That's the arc measure, or that central angle measure. Those are the same. Out of my whole, which is 360. Okay. On the other side, it's asking me to find the arc length. Well, that red, anytime we want to find something that's unknown, we're going to call it x. So I don't know what the arc length is, that part. I don't know the part. So I'm going to put that in the top. And in the bottom, I'm going to put the whole circumference. Well, my whole circumference is 2 pi r, and in this case, the r is 8. Okay, so we just have our angles on one side, part to whole, and our circumference and arc length on the other side, which is part to whole again. And so just to how we want to maybe think about this, I'm going to call this 60 out of 360. And sometimes I would take time and simplify these fractions and things like that. But if we have a calculator, I'm not going to worry about that. X over, the only thing I am going to simplify is 2 times 8 is 16 pi. Now we are going to cross multiply with our butterfly method here. And we would get 360 times x equals, well, we're going to take 60 times 16, which is 960 pi. Don't forget that pi is still there. All I did was I multiplied 60 times 16. Okay, and what am I trying to get by itself? X. So now I'm going to divide both sides by 360. And again, I am not worried about trying to simplify these fractions just because it is basically all going to go into your calculator. So x, because that's going to cancel, 960 times pi divided by 360 is 8.38. We need to make sure we label in centimeters. Make sure you actually go and put this into your calculator to make sure you know how to enter it correctly, to make sure you're getting 8.38 also. Okay, this next one, they want us to find the circumference. Okay, so if we want to find the circumference, again, one side is going to be our angles. So we're going to have 40 out of 360. That's the part to whole for my angles. The part to whole for the other side, remember the numerator, I need to do a little thought bubble here. Okay, remember we have arc measure out of 360. That was one side that was the part to whole. And then we have arc length over our circumference, which is 2 pi r. I'm going to put it into words here, divided by our circumference. Okay, so if we're thinking about that right there, and we are finding, we have arc measure over 360, arc length. Well, we already know the arc length. It tells us it is 4.19 inches from x to y. So our numerator is going to be 4.19. And our denominator, it asks, what is the circumference? Doesn't tell us the radius, but we don't need to know the radius because the circumference is the whole. That's the piece that's on the bottom. So we're just going to put x on the bottom because we want the whole circumference. And if we go ahead and we do our cross multiplying, we get 40x equals 1508.4, because I just cross multiplied here. 40 times x, 360 times 4.19. If I divide 40 on both sides, I get that x equals 37.71 inches, which means based on that information, we should always go back and make sure that things make some sense, right? So if this part from here to here is 4.19, all the way around should be about 37.71. Just kind of check to make sure your answers make sense when you get done. Okay. The next one, when it looks like this and it says the m, little lowercase m in front, that's saying the measure of arc RS. Okay, which means we want to find an arc measure. So if we're looking back at our little thought bubble up here, right, the arc measure is the part out of 360. Well, I don't know that part, so I'm going to put x out of 360 equals, okay, my arc length. Well, I know my arc length is 44. And I can figure out the whole circumference because it tells me the radius. So I'd have 2 pi times 15.28. Okay, and then if you go ahead and do some cross multiplying, 360 times 44, going this way, is 15,840. And then the other way, if you multiply 2 times pi times 15.28, you get 30.56 pi times x. Well, we want x all by itself, so we're just going to have to divide out that 30.56 pi. And be careful when you're putting this into your calculator, because you know sometimes your calculators like to do order of operations a little bit differently. You might need to put, depending on your calculator, you might need to put that denominator in parentheses to make sure that it doesn't divide before it multiplies. But if you did it correctly, you should get that it is approximately 164.99 degrees, which is about 165 degrees. Okay. Okay, so here are 3 more questions that you can go ahead and try on your own. Pause the video, see if you can figure them out. I will put the answers up there here in just a second, so you can check to see that if you are correct or not. Okay, so after you've had a few minutes to go ahead and check that those are right. If you have any issues with getting these answers, you can go ahead and email me, let me know, ask some questions, go into the Zoom time with the math teachers on Tuesday or Thursday, but you always have opportunities to see if there's something else that you can get help with. Okay, so now we just have a few questions here where you have to think a little bit about what the picture actually asks you to do. So this one asks you basically to find the perimeter of the shaded region. So we need to find this distance that goes here, 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 and here. Well, we have a rectangle, so we know if this piece is 13, we also know that this piece is 13. Okay, but then we need to think about what we have with these arches here on the end. We have 2 half circles, well, also known as a semicircle, but if you have 2 semicircles, they make a whole circle. So basically those 2 circles that we have here, if you put them together, they make a whole circle with a diameter of 6. So if we can figure out what the circumference of that whole circle is, that's essentially like going this half and that half. So all we really need to do is we need to find the circumference of a circle, of one circle, because remember it's 2 half circles, of only one full circle with a diameter of 6, which means I would have the circumference equals pi times d, which equals 6 times pi. And if we multiply those together, we get 18.85. So that red represents these 2 halves right here. Well, if we're going to go all the way around the blue, we'd have that first 13 right there, plus both the half circles. We can add those together at the same time. You'd have 18.85 plus the other 13 from the other side. When you add those all together, we get 44.85. Does not give us any units, so anytime we're doing these, we always need to make sure we label. That would be in units. Okay, here we have a little bit trickier one if you want to think about it. We need to do the blue, right? So the blue is this part here and this part here, and then those two straight pieces. Well, the straight pieces are easy to figure out. That's 6 and 6. What we need to think about is what these parts here represent. Okay, well, we have 90 degrees and 90 degrees, which means you have two right angles, which means that's basically a fourth of the way around the circle. Well, we have two of those fourths. If you put them together, it's a half. So this plus this is a half a circle or a semicircle. I'm going to erase that so it doesn't get so crowded in there. So if I need to find the circumference of a half of a circle, just this part plus this part, that's a semicircle. Okay, and we're working with radiuses. So I would need to use the circumference equals 2 pi r. That's a whole circle. However, I don't want a whole circle. I want half the circle. So having a half means I would divide by 2. And when we think about that, our 2's are going to cancel out. So the circumference of a semicircle is just pi times r. So for that semicircle, it would be 3 times pi, because our radius is 3. And the circumference of that particular semicircle, if we multiply that out, is 9.42. So we would have, here's our circular part, and we also have the two straight pieces. So we would have 6 plus 6 plus 9.42. When you add those all together, you get 21.42. Again, we don't have units here, so we just call it units. So that would be our final answer. This down here was just our semicircle. Okay, so now this is how it's going to work. In Schoology, this is just part 1. Okay, there are 2 parts for this week. 11.1, there's going to be a practice worksheet, 7 or 8 questions just for you to practice on. There's also a solution key that is posted there. The practice worksheet does use 3.14 for pi. I made the answer key before I realized that Big Ideas used the actual pi button. So make sure on the practice worksheet, if you're a little bit off, that might be because you're using the pi button instead of 3.14. There's also a Big Ideas online assignment. It uses pi. So if you keep getting your Big Ideas questions wrong, make sure that you're using the pi button and not just using 3.14, because remember, pi is actually an irrational number, goes on and on and on forever. So these practice problems prepare you for the demonstration of mastery. Once they're completed, there's another short video on 11.2 that has the same thing, some practice worksheets, a solution key, and a Big Ideas. You are not required to submit any of the practice stuff. Okay, so all of the practice things, all of this stuff up here is practice. There's not a submission box. There's nowhere that you need to do anything with it. Okay, so these are for your practice. Keep in mind, I can check to see if you've done Big Ideas or not. I do not put you in ICU for the practice stuff. The only thing you get put in ICU for is the demonstrations of mastery. Okay, so after you've done this 11.1 to the point where you think you understand the material, then you move on to 11.2, do that video and the practice. You do not have to do every single question in the Big Ideas and every single question on the practice. If this is something you feel comfortable with that you can do, you can not do every single problem, but you do need to do some problems from each, okay? And then when you get to the point you finished 11.1 and 11.2, there are questions in the demonstrations for mastery over both sections. So don't submit anything until you've done both sections for this week. And then you can go ahead, make your mastery video and submit that. And that is what gets graded. That's the only thing that gets graded and gets put in ICU is those questions in the demonstrations of mastery. hopefully things are going well, and I look forward to hopefully seeing you someday.